Hello friends, today we will do the derivation part of the Heisenberg uncertainty principle. So, for its basic idea, what the Heisenberg said that we know that the electrons just orbit around the nucleus. Okay? Classical high school and secondary school chemistry and physics tell us this. Okay, but this is not true. Actually, it's not true. It's a false statement. Electron is not a particle. Many people think that electron is a particle. It doesn't act as a particle. Yeah, it acts both as particle as well as the wave. Both nature it shows, but with higher quantum mechanics, we consider it more like a wave. Electron is not a particle. Electron itself like a cloud. We have cloud of electrons which has a probability where the electron should be, like here or here. We don't know the position and the velocity of the electron at the same time instantaneously. That's what the Heisenberg said that. Heisenberg said that change in the position into changes momentum is greater than equals to h bar by 2. It's a mathematical representation of the Heisenberg principle. Okay, so today we will derive and understand what the Heisenberg wants to say. For the context, first of all, there is a person called as Fourier. He gave the very good equation delta x dot delta k greater than equals to 1 by 2. He was a mathematician. He gave it in the early 1800s type-ish. That this is the wave number. In mathematics, we study waves, not in just physics or chemistry. We also study about waves in mathematics. So Math 2, what is K? K is the angular wave number. It tells us about in 360 degree, like this is a 360 degree, and if we divide it by its distance, 360 degree divided by its distance, which is like lambda, we get a term called as wave number. And at its angular, like angle, so we call it angular wave number. Okay, so we call it as the wave number. So Fourier did the math, which like phi x is equals to 1 by under root 2 pi into integration of probability, which is chi x dot e raised to the power minus iota k x dot dx. What he did is he just assumed delta x square is like change, so x square and x whole square, and change in the wave number like this. This is called as Langle and Wrangle. So we do the integration of f square dx into mod also into g square dx greater than equals to of f g whole square dot like whole square dx. So here f v dot x, so x square dot x square for dx, which gets us to be delta x square. Here we had made an assumption that we start from the origin and this and this are just 0. So we can directly say this is equals to delta x square, and we take this as d by dx. So integration of d whole square dot dx as, so in that d by dx is iota h on its momentum operator, so we can directly write as it as k square, which we can write as delta k square. And if we differentiate this term like integrate this one x square root x into d chi by dx whole square dot dx, we get 1 by 2. So we can just like that delta x square dot delta k square greater than equals to 1 by 2 whole square. Okay, so we got that delta x square dot delta k square greater than equal to 1 by 2 whole square. So we can also write a delta x dot delta k greater than equal भी आता है 1 by 2. So as we derived that k is equals to n by r in our earlier derivation, which is also on this channel, we know that k is equals to 2 pi by lambda, and lambda we can write as h by p. Okay, so you can write delta x dot 2 pi p upon h greater than equal to 1 by 2. So we have delta k, so we can write here delta p, delta x dot delta p greater than equals to h upon 4 pi, or we can write h bar by 2. Both are just the same thing. So derive today. Okay, so hope you enjoyed this video, and I will come back and will teach quantum mechanics after some time. So bye bye.